Inequalities for College Algebra. Let's first start by talking about principles for solving inequalities. Note that when we add and subtract inequalities just like we would an equation, we can also multiply and divide inequalities also just like we could with an equation. However, it's very important to remember that when we multiply or divide by a negative number, our inequality sign would switch. Now, it doesn't matter if we're using less than, greater than, or less than and equal to, or less than or equal to. The rules still apply the same. Let's first start by solving each of the following and then graph the solution set. Currently, we have 3x minus 5 is less than 6 minus 2x. What we first need to do is add 2x to both sides so that we can get all of our x values together. By doing so, we end up with 5x minus 5 is less than 6. I'll add 5 to both sides so that now I have 5x is less than 11. And when I divide by 5, I see that x is less than 11/5. Now remember, there's two different ways with which we can write this. We can write this in set builder notation, x such that x is less than 11/5, or we can write it in parenthetical notation as well, from negative infinity to 11/5. Note that because we're using less than, this will be excluded. And of course, using infinity is always excluded because there is no definite endpoint to infinity since it goes forever. So because we're having the sign less than, we will use a parenthesis. Now, if I want to graph this, I'm going to, at 11/5, put a open dot. And I need numbers that are less than this. So numbers that are less than 11/5 go to the left-hand side, which is the direction in which I'm going to put my arrow. 13 minus 7x is greater than or equal to 10x minus 4. Well, the first thing I'm going to do is add 7x to both sides so I can get all of my x values together. I'm now left with 13 is greater than 17x minus 4. When I add 4 to both sides, I have 17 is greater than or equal to 17x, and then divide by 17 so that x is by itself. Note, because I divided by a positive value, my inequality will stay the same. This is also the same as saying x is less than or equal to 1, whichever way is easiest for you to see and understand. Written in set builder notation, I have x such that x is less than or equal to 1, or in interval notation, from negative infinity to 1 inclusive. So this time, because we have greater than or equal to, we will use a bracket because that means that it's included. Now when I insert my dot, I'm going to have a closed circle because 1 is included, and I want numbers that are less than 1, so my arrow going to the left. Let's find the domain of the function. I have f of x is equal to the square root of x minus 6. We know that square root functions have to be greater than or equal to 0. So I'm going to solve inside my radical. I'm going to set it greater than or equal to 0 because we know we can't take negative values of the square root. We would end up with non-real numbers. Solving then, I see that x is greater than 6. Our set notation would be x such that x is greater than or equal to 6. Or in interval notation, because it's included, we'll have bracket 6 to infinity because that's the direction in which our values would get larger. Similarly, we know that we can't divide by 0 either. So I'm going to make sure that when I set my inside of my radical greater than 0, I'm not going to use equal to because if it was equal to 0 in our denominator, we still wouldn't be able to do it. So I'm going to set it greater than 0, not equal to, because it's not inclusive of 0. Subtract 3 from both sides. And this time, remember, I'm dividing by a negative 1 to get x by itself. So when we divide by a negative, notice I flip my sign from greater than to less than. So in set notation, we have x such that x is less than 3. And we also have from negative infinity to 3 parenthesis because it's not included. Let's solve -3 less than 2x plus 5 less than or equal to 7 and then graph our solution set. So we really have two different pieces here. We have the piece that's -3 is less than 2x plus 5, and we also have 2x plus 5 is less than or equal to 7. So we're going to tackle this by solving for the middle. So we're going to solve and put x in the middle. To do that, the first thing I'll need to do is subtract 5 from all three places. By doing that, I'll end up with -8 is less than 2x is less than or equal to 2. Then everything will be divided by 2. So I have -4 is less than x is less than or equal to 1. So in set builder notation, I have x such that x is between -4 and 1, or if we put an interval notation, x has to be between -4 excluded and 1 included. When I put my dots down, then I'll have an open dot at -4 and a closed dot because it's included at 1, and our x values can be in between that. I have 2x minus 5 is less than or equal to -7, or 2x minus 5 is greater than 1. Then let's graph. So we really have two different ones that we're going to solve for here. I'm first going to solve for 2x minus 5 is less than or equal to -7 by adding 5 to both sides. That will leave me then with 2x is less than or equal to -2. Dividing by 2 shows me that I have x is less than -1. Or, solving the second one, I'll add 5 to both sides, so now I have 2x is greater than 6. And when I divide by 2, I have x is greater than 3. In set builder notation, then I'll have two different pieces because there's two different intervals with which x is true. X such that x is less than or equal to -1, or x is greater than 3. And how we would write this using interval notation, we know our values are going to be less than -1. We're going to hop over some stuff, and then we're going to start at 3 and continue to get greater. So I'm going to have from -infinity to 1, bracket because it's included, union, so I'm going to skip over from -1 to 3. I'm going to start at 3, excluded because it's a greater than symbol, and continue on to infinity. So it looks something like this when we graph. All of our x values, including -1, will be less than. We're skipping this stuff in the middle. We'll start at 3, excluded, and then continue to infinity again. For her house painting job, Erica can be paid in one of two ways. Plan A is $250 plus $10 an hour, or Plan B, $20 per hour. Suppose that a job takes n amount of hours. What values of n is Plan B better for Erica? So we want to know, when is Plan B greater than Plan A? So let's just take a guess here at 20 hours and see what we come up with, just to familiarize yourself with the problem. So if I worked 20 hours, I would have $250 plus $10 times 20 hours, or $250 plus $200 for $450. Plan B, on the other hand, would be 20 times 20 hours is $400. In this case, Plan B is less than Plan A, not exactly what we want. So let's up how many hours and see if we can get a better understanding. Let's say we work for 30 hours. So $250 plus 10 times 30 hours is $250 plus $300, or $550. Plan B then would be 20 times 30, or $600. In this case, Plan B is certainly better than Plan A. However, we want to know what is the exact value that this happens. So when we translate this into an equation, we want our Plan B income, which is 20 times the number of hours, to be greater than Plan A at $250 plus $10 per hour. At this point, we can solve for n. We will subtract 10n from both sides, giving us 10n is greater than 250, divide by 10 so that n is greater than 25 hours. So if I take then 250 times 10 times 25 hours, we get a total of $500. If I take 20 times 25, we also get $500. So when the 25 hours is what we used, the income which we receive is exactly the same. So we need to make sure that we're working greater than 25 hours, not equal to 25 hours, for that plan B to be better for Erica. And this concludes our lesson on inequalities.